Well, thank you everybody for joining us this afternoon in our session on creating a unified logon experience on mobile devices. So today, within this session, we want to share some knowledge that we've gained the past, let's say, 3 years, I think, on how to create mobile experiences and especially connect with cloud platforms, in special Windows Azure, which we will show today. So you already might notice that we have a kind of a funny accent here. And so we're coming from the Netherlands. My name is Marcel. I'm a technology manager at Info Support. I'm also an ALM MVP and a regional director for Microsoft. Roy?
My name is Roy Cornellisen. I also work for Info Support. I'm a software architect and also a mobile community lead. So together with Marcel, we head up the mobile developer unit. I work with Xamarin a lot for the last few years. So technology we both grew to love and use in the practice.
Yeah, and especially a Xamarin insider as well. So we work together with Xamarin a lot on the early alpha and beta stages of their products. So, so the Dutch guys, we're from the Netherlands. 11 people from the Netherlands appeared here in this conference, so that's good, I think. So the Netherlands, for people who don't know where the Netherlands is, it's more the northern part of Europe. Most of people know us from perhaps the tulips and the nice flowers that we grow there. We're also famous for the cheese, the Gouda cheese, that you might be familiar with as well. And we're also famous for art, like the Van Gogh or Rembrandt Museum. But of course, yeah, if you talk about Amsterdam, if you talk about the Netherlands, probably people know us best from the coffee shops and the red light district. So yeah, that's more or less how people know the Netherlands. But with no further ado, just get to the agenda. So today, what we would like to present here today is first of all how we perceive the problem in getting access to certain resources that you might have in your enterprise that need to be secured. Or you need to get access to a service and you want people to log on to that service. And we are going to propose a certain set of solutions that we have found working for us very good. And we will show you that with some real life examples on apps that we've built and how you can leverage that yourself later on. So if you take a look at the problem statement here, so what we're looking at is you have a service, something that you would like to expose in your mobile app, but you want to do it in a secure way. So first of all, if you don't want people to eavesdrop into the communication, you could use HTTPS as a protocol. But what do you do with authenticating that user once it gets into your service? How do we make sure that we know that who's that user and can we trust him, yes or no? So to do that, you need to have some way of authenticating that user against your mobile backend service that you have. And the question is, how should you do that? Now, if we were in the 90s of this era, then what we would have seen is that we would roll our own username and password and go from there. But there are so many identities that you already might have living around on the internet with your Facebook account, your Google ID, your Live ID perhaps. So why would you roll your own again and again and again? And why not leverage one of those cloud identity providers instead, so you don't have your users to log on to your service and remember another username and password and forget it again and have all kinds of calls back to your company and resetting passwords, etc. So to solve this problem, wouldn't it be nice if we could just integrate with those identity providers in the cloud? And that's what we try to achieve here in this talk. So if you take a look at identity providers, there are more or less two ways of looking at them. So first of all, we have the notion of enterprise identity providers. And those identity providers might be in your Active Directory in your company, or might be in a federated fashion where we have ADFS, for example, and that might be opened up to the public. Now, from a corporate perspective, that's most of the time where you need to authenticate against. But there are also solutions where you could authenticate against, for example, social IDPs. So when I talk about an IDP, I mean an identity provider here. So the IDPs that you come accustomed to are probably Facebook or Windows Live ID, Google ID, Yahoo. I don't know if Yahoo is big in the US. I know for sure that in Europe nobody uses it, but I hear that people are using Yahoo here in the US. And a lot of people use OpenID as well. So there are two ways of looking at it. First, you have your enterprise environment, and then you have the cloud and the web, where you could have a certain identity, and we would like to leverage that within our apps. So first of all, what's the responsibility of an IDP? That's a big question, right? And what an IDP needs to do is it needs to authenticate you against something that you know or something that you have. Okay, so that's more or less the way it works. So you can provide a password, you can provide a smart card, perhaps biometric information, all kinds of ways to make sure that they know who you are, and based on that provide you an identity on the web. Now, an IDP hands out what we call a token, and that token contains a certain set of what we call claims, and those claims are assertions on who you are and what they know about you. And we can request at an IDP that we would like to have a token, and a token that we would love to know, for example, what is the unique name identifier of that person, so that we uniquely can identify it within our application's backend. Okay? So those are the things that you can request, and you see that different IDPs provide different claims, and you can figure out which claims you can map against something that you need to use within your application. Now, the fun thing about these IDPs is that you can chain them together. So what does that mean? Well, we can say, well, I am trusting a certain identity provider, but if that identity provider trusts somebody else to do the authentication instead, you can just forward the request to that other identity provider. So that way, we can chain them together. So for example, if you would have something like my Active Directory would also trust the Facebook IDP, you could chain them together that once somebody tries to authenticate against your Active Directory, they could be forwarded to, for example, Facebook to log in. Not that it makes a lot of sense in the Facebook example, but it does make a lot of sense if you take a look at, for example, enterprises where you will cooperate with other companies that also might have an Active Directory, so you could forward the request to their Active Directory and that way federate around. Okay? So with that, what you get is that IDPs get chained together, and once an IDP returns data to the IDP that forwarded it, it can annotate the claim set and forward it back to the one who requested it. So that makes that an IDP can not only hand out tokens, but it can also annotate the tokens it got from another IDP. And based on that, you can map it back to something that is more common and is something that we will make use of today when we talk about the way we solve this problem. Okay? So if you take a look at the IDPs, we now know what an IDP does. But if we then get the data back and we get some claim back from this identity provider, then the big question is, what do we need to do with that? So if you take a look at how this works, is that we can now look at a certain claim that comes in, and I put here the name of such a claim, which is in a very nice long format where you need to figure out which is the end game there. So name identifier would be something, email address would be something, and this all would be predefined set there before, which is standardized on the internet. Okay? Now the whole idea is that based on this ID, I can do additional stuff. So the identity provider provides authentication and gives you a claim back, and then based on the claim where we've got authenticated, we now need to authorize ourselves. Okay, so there's this game of getting an identity, and then your app does need to do something to look up that identity, and based on that, grant you access to certain stuff. Okay, so that's clear. So we have authorization and authentication going on, and authentication is what we push out to the cloud. So what are the possible solutions for this if you have a backend service and you would like to secure that with such an IDP in the cloud? Now, what we could do is we could just integrate with any of these IDPs. We could just go to Facebook, create a Facebook app, based on the Facebook application, get a security token, and integrate that with a protocol that they describe, and then do the forwarding of the data and getting the tokens back in some way or format. The same we could do for integrating with ADFS. We could do that with Live ID. But the thing where you run into is that you need to do that over and over again for each identity provider, which might roll their own protocols and their own ways of doing stuff. And there's some standardization going on there. For example, you have OAuth, which is more or less giving you a token, and on behalf of that token, you can access a resource that you authorized for that user. But we also have notion of WS Federation, SAML OpenID, all kinds of protocols that you then would need to implement within your application to make this all work. And every time you need to add a new authentication provider, you need to craft something up in your application again and again and again. And the fun thing is that if you do that, well, at least you keep being busy, at least, doing that. But there is a different solution that we would like to take a look at this afternoon, and that's Windows Azure Active Directory, where we can make use of what we call the Access Control Service, ACS. Okay, and ACS is this IDP in the middle that can forward your request to any other IDP, annotate the claims, and then forward it back to your application. And based on that, we can then standardize on a set of claims that we would like to see and do the lookups in our service backend. Okay? So if you take a look at ACS, ACS is part of the Windows Azure offering, and with ACS, they provide more or less the central hub to configure all these identity providers that you would like to integrate with, and then hand that back to you as one thing that we need to integrate with, and that would be the identity federation that ACS provides. Okay? And the fun thing is, and I will show you just in a few steps how you can do that later on, how you can just integrate that very easily with your services backend, which might be a SOAP backend or a REST backend where you would like to get your data from. Now, out of the box, they provide hooks or identity providers to Facebook, Yahoo, Windows Live ID, Google ID, and they also provide a plugin mechanism to work with any WS Federation identity provider or any OpenID provider. And we can just plug them in as we go along. So if you would like to integrate with your ADFS, but you would like to perhaps let people authenticate against Google ID or Windows ID, you can make use of both your Active Directory and those social providers in the cloud. And that's one of the things that we learned is very handy because, well, it's a very easy way of adding more identity providers in a way that we don't have to tweak our app, and our app can even adapt to the fact that we add an identity provider without making any changes in the apps that you build on your mobile device. So with that, let me first show you how you can secure a service that you have running, which is just a basic web app that I have over here. So what I have over here, I have an ASP.NET MVC 4 application running. When I do Control F5, you will see that it will just open up the website for me. And of course, now I have a network connection problem. There it is. And what I've done is within this website, I added services. And those services would be, for example, just a SOAP service that would be available there. But this is a special service. This special service can talk many different protocols. So it could also talk, for example, JSON. And then I could do something like get events. And when I do that, you will see that I get a dialog box here of downloading the JSON result. And when I open that, you will see that I got the JSON results back. Okay, so this is the way I get my data from my service, which is just plain vanilla ASP.NET MVC. And what I've done is I've made use of RIA services because you can just plug in any endpoint you'd like, so SOAP endpoint, JSON endpoint, and also no data endpoint, which makes it very easy to switch between different protocols depending on your needs. Now, here you see that I use, for example, SOAP UI. And SOAP UI makes a SOAP call to this exact same service. And when I click it, you see that I get the sessions back from my service. And that's the way we're going to look at this service. But now it's open for everybody. Everybody can get the data. And I want to secure this. So how can we do that in an easy way? Now, for that, what we need to do is we need to go to Azure. And within Windows Azure, you can select Active Directory over here. And if you go to Active Directory, you can create what they call an access control namespace. And this is an ACS namespace which you can set up to work with a certain set of identity providers to provide your authentication. So what I've done here is I have this VS Live namespace that we're using, and when I go to manage, I'm logging into a portal, and this portal now provides me a mechanism to configure what they call the identity providers, for example, Google or Windows Live ID. And I can just add any other provider here like Facebook or a WS Federation provider like Active Directory Federation, for example, or any other provider that might talk that protocol. So once I added these providers, then what I need to do is I need to configure who is relying on this authentication to happen, and that's what we call the IDP, or the relying party. And the relying party is what we configure over here. And you see that I have my local host being set up as being one of the guys using this ACS namespace. Now the fun thing is once you've configured this, the only thing you need to do here is in your web application is right-click and go to Identity and Access. Now Identity and Access is one of those plugins you can download from Visual Studio Gallery. And it will provide you with a plugin to just make all the annotations in your web config to make stuff work with any identity provider that you'd like. For example, using Azure Access Control Service. So when I click Configure over here, I can say, well, I would like to use the VS Live namespace over here, and I would love to use this token over here, which is a way for me to authenticate against the ACS to plug into their service or management APIs. So it can do the configuration from Visual Studio for you. So when I click OK, it will verify me. It will see that we have Windows Live ID and Google as the identity providers now. And once I click OK, it will make the changes in my application. So now I require authentication each and every time I go to this website or to one of my services. Okay? So when I would do a Control F5 again, and I would go to this application, what you will see is that it will now be forwarding it to ACS, and ACS will give you a set of identity providers. You get the two of them over here. And now I can just click on any of those. So I could go to Google, for example, and punch in my Google ID over here. Or what I could do is just go to Windows Live ID, and because I'm on a Windows 8 machine, it will authenticate me right away because it has the Live ID integration going on. Okay? So now I'm authenticated, and what you see is that now my app says, hello, some token that I have over there, which is now my unique identifier. Okay? And based on that, I need to do some identification on the back end and see, oh, who is that guy, and what can he do, and provide some roles that he could use. Okay? So yeah, the unique identifier is different from any IDP. The only guarantee you have is that it's unique. Okay? And one of the things you need to be aware of if you're using Windows Live ID, based on the application that's authenticating, you get a different identifier. So if you authenticate as Marcel for application A, the token is different than for application B. So you always get a different token, so you can make assumptions on the IDs there. I think with Google, I'm not sure, it was the email address, right?
Google will actually give you your Google ID, so your something at gmail.com, for example.
Yeah. So that's more the simplistic way of doing also some way of tying those accounts together. And that's harder to do when you use Live ID. They're very reluctant to give you anything away of the end user. And based on this key, we can now authenticate back again to Windows Live and say, I would like to know its email address and other stuff. But then for that, we need to use a different API. And we can use this token for that. Okay? So what you see here is that in the meanwhile, I had here this application running here, which now shows the way that I'm connecting to this application. And if I go to the raw view, what I should be able to see is that it does move here. Let me see where it is. So what you normally see is that you get the cookie over here. So you see here that there's a cookie, the login cookie. And now you see that this is the cookie that we got to do the authentication. Okay? So I could copy this header over here. And because when I do SOAP UI and I would do a call here and would do a call, and I would get a request is not valid because I cannot answer it. And what I could do is I could say, well, I would like to add a header over here. I would like to do a cookie as the header, and I could just paste this in here. And now I should be able to authenticate against. Oh,
you need the other one as well.
Oh, I need the other one as well, so I need 2 cookies.
What it actually does is it gives you a token, and based on the size of the token, it splits it into multiple cookies as far as the cookie size limit goes. Yeah. So in this case, he gets 2 cookies.
Yeah, so I need to get rid of this, and this is fedauth 1 and fedauth, right?
Yeah.
And they're the same, so I think I should be okay with 1. The thing is that I pasted in the cookie format as well, so I think this should be okay. So here you have it. So now I'm authenticated against this service, and now I know who's the identity. And in the backend, I have a little piece of code that decodes that identity. Okay, so if I go to the controller, to my home controller here, the only thing I've done is not the login, the home controller. I have this notion of get user identifier, and if I do F12 that, the only thing I need to do is from my HTTP context.user, I can now get what they call a claims identity, and for the claims identity, I can look up the unique identifier for that specific person. And that's the way I now know who it is, and based on that, I can do authorization. You could plug in any authorization module you'd like to make this happen, okay? So that's the way we do a service backend and secure that in a secure fashion. Yeah.
All right. So now to the app. First of all, there's a couple of concepts I'd like to run through. One of them Marcel already introduced, which is the IDP, the identity provider. But just a couple of terms that you'll find in when you're working with these security protocols. An STS is a security token service, which is actually a service that hands out tokens. And these are the parts that can be changed. And an STS can also be the eventual IDP, such as Google or such as LiveID. But each of the steps in between an authentication chain can be an STS. It issues tokens. And those tokens can be passed to the following STS, maybe augmented by one of them, and then packed into another token, and up until it reaches the app. The relying party is the actual application that relies on some STS to give him a token, and there's a trust relationship between the relying party and the STS. So the relying party relies on the authenticity of the tokens that the STS issues. So actually that's your app.
Yeah, so the trust that we just created in the app, it's in your web config. You see an exchange of a cookie or a unique identifier there as well to tie it back to the ACS. So that's the way you have the trust boundary between those. Okay.
So when it comes to tokens, you have a couple of choices. You can go for either SAML or simple web tokens. And it kind of depends on your situation, your scenario your app is in. SAML is a protocol, simple assertion markup language that packs a token into an XML format, signs it, and sends it over to the consumer. And it contains claims and methods to secure the contents of that message, that token. A simple web token is a bit simpler. It just gives you a token, encrypted, and it sends you back, and usually you can send it as an HTTP header and use it that way. And it's a bit simpler than SAML. SAML is more elaborate protocol, but also allows for more flexibility. And what you would use is depends on your service, depends on your application. So if we would go call a service with simple web tokens, let me just stand here. Usually, you use that in a REST scenario where you just do a web call to a service, for example this, and you just add a header to the HTTP request. So it's just authorization, and you put the header value, which is just a string token, into the HTTP request, and from then on, that HTTP request is authenticated. So if we would be using WCF or SOAP services, and assuming that you would be using WCF, it would become a bit more complicated because every service call that you do needs to be authenticated. So every service call you need to do, you need to put the headers onto the HTTP stack, and then it would send it with it. So it's a bit more elaborate piece of code if you would use WCF. Is a question?
So this is the app sending the authentication token back to the server?
Yeah, this is the client app sending, doing a service request and needing to authenticate. Correct. So the other way around, if we would use a SAML token, which is a bit more complex, you see that if you would, assuming that it is in a cookie that you would need to send along with the HTTP request, you would need to go through all this hassle to add the cookies to the web request. Would you be using a REST service? So a bit more hassle. In WCF, it's a bit more simpler. You just use a cookie container. You assign a cookie container that you use shared in your app that you've put the cookies in, and it'll use it on every subsequent WCF call. So depending on the type of service and the type of protocol you use, SWT or SWT or SAML would be a better choice.
You can't use the cookie container with a web client?
There's not, well, what you're actually doing here is you adding it to the cookie collection there for the web request. But the thing is you need to do that for the web client itself. And you need to add the headers each and every time, and you don't get to touch the cookie collection, and it will not do it automatically for you.
Plus the cookie container here is a property on a proxy, and the proxy you typically use multiple times on subsequent service calls. So you just assign it once, and it will use all of the time. And here you need to add it to each request. So that's a trade-off to be made. So when it comes to the app, there's a couple of things. First of all, when we build apps, especially using Xamarin, we build native apps. So we don't use a website or a web browser that we browse to a website and then land into an HTML application. We have a native app, so we want to use that native experience and we want to do the login, that same login as we saw that Marcel did, from a web app, from a native app. So we did a couple of things to facilitate that. So here are the parties again. We have the ACS, your web service, might be either a SOAP service or a JSON service, doesn't really matter, and the actual identity providers. So what we did is we created a control that when the app fires up, it issues a call to the ACS and it says, get me the list of identity providers that you support.
And that's what we configured in the website, right? In the ACS configuration, we configured the IDPs that we would like to have, and we can get that list back.
So when Marcel did the demo, you saw a list of 2. In this case, you saw a web page. So that can also be requested from the ACS in a JSON format. So we issue the call to the ACS and say, give me your identity providers. It is shown in a native user control, which just show the list. And in this case, it's a Windows Phone application that just uses a list view. And when the user selects an identity provider, it'll go authenticate against that identity provider. And we'll see in a minute how that works. So you get, and this is actually a web view here embedded in the app, but you get the web experience logging into the identity provider of choice. So Windows Live here shows a mobilized version of their login page. You can also use the Google login. And you actually authenticate on the identity provider's website here. Then it'll just close after the user does that, it'll just close the login screen and do the authentication against the identity provider. It will send the token back to the ACS and ultimately back to the application. So the application will get a token from ACS with which it can go ultimately to your service. And there's a bit of magic here going in front of your service called WIF. So it's the WIF stack that actually handles the decryption and the translation of the token you got from ACS and turns it into an application token. So here in your app, in your WIF stack, you can also plug in some stuff and do an augmentation of your claims. Say you get a name identifier and you can also add more claims to that. For example, your role or maybe information you have about the user that's not in the identity provider but it is inside your app. And you reissue a new token and that actually eventually goes to the application, to your app on the phone. And that is all done via a simple ASPX page. It returns HTML, and along with that comes the authentication cookie that your app issues. And that cookie is used on all subsequent calls to the backend services of your application. So there's a whole login dance with several parties involved that ultimately lets you get a login experience with different identity providers.
So when you get the redirect back from ACS, basically you're getting the authentication token back, right?
You're getting the authentication token back, translated into a token issued by the ACS. So actually there's only a trust relationship between this backend application and the ACS.
So that would come back into the web view, then do you need to somehow...
Yeah, we will show you later on. So we will go through a little bit of demoing there. So how does it work with the magic dance, and who does the magic dance?
Yeah.
Do we need to do it, or can we just delegate that off?
What actually happens on every hop is just a 302 redirect.
Okay.
And the browser just follows along until it reaches the application and gets the cookie back, and then it closes the login screen. We'll see that in the demo.
But the app doesn't need to grab that token?
So we grab the token. I will show you later how we do that, and it's different on the different platforms how you can do that. But we encapsulated that. Yeah.
So when it's authenticated, then you can access the service and get the data and show it. And from then on, it's all in your app, and your app uses the token.
Yeah. So first of all, we would like to show you what the login experience is. And what we've done is we've created multiple applications here. This is one of the commercial applications that have been built for, you could call it Best Buy in the Netherlands. They sell on an auction site stuff that has scratch marks on it, and you get it for cheaper. Here you see that you can log in, and here we provide the log on experience where you can select the identity providers, and based on selecting the one, you go in, log in to that, and based on that you get into the application. Now, I'm not showing you this in real life because my resolution just got bumped down by the beamers or the projection screens. So, and Windows will not open any Windows immersive app when your resolution is lower than whatever resolution they like. So that's the reason I'm not showing that. So what I would like to show you is another application that we have, which is the events application that we built for our company. And this application, and I'm showing this on Windows Phone, and Roy will show it on Android and on iOS, is that we provide here the exact same logon experience. So we now go out to the web, get the IDP list back, and next what I can do is I can click here on Windows Live ID, and it will now show me the logon screen. So this is the web view that now shows the logon screen which you get from the web. The only thing I need to do here is just say, well, I am Vries Marcel. I am Vries Marcel at hotmail.com. And what I can do here is I will paste in my password, otherwise you could see it. And then I will keep myself signed in. So now when I sign in, it will go out, do the magic dance. You saw a little flicker there going on that has to do with the redirects going on. And we say, well, we know which URL you're on, and we're not showing you anything anymore, but we do the dance behind the scenes. And then it logs into the application, and now it can access our services using that cookie that just got sent over. And now we can just access the sessions that we have in our backend system. Okay, so the fun thing about this is that we also store the cookie on the device. So now for the lifetime that we issued the token, and that can be, for example, 24 hours on ACS, when I now click the application, it will go right in there, and it can authenticate me and reuse the cookie for a longer time as we expect it to be. Okay, so that's the way you can do that, and that's the log-on experience we created, which can be used on Windows 8, Windows Phone, and Roy will show you that that we have that on Android and iOS as well.
Correct. Just to show you the login experience here, I fire up the Android app, which is basically the same app. And you see that it looks a bit different. It looks Android-ish, but it does the same thing. It just gets the list of identity providers from ACS, shows it here. In this case, we use the logos as well. It will also return the URL for a logo. And I'll use Google. And I've signed in before on this device. So it'll just do the login for me. And ultimately, you'll see that it's it's signed in. So actually the browser has remembered my, my Google ID, and it just used that under the covers and logged me in, got a token, and I'm in here. So I can see all the sessions here. The same thing with iOS. It fires up, and I've opened this before, so I'll just log off first. And you see that it also gets the list. I'll choose Google here. It does the same thing, and I'm in the app. So that's the basic experience.
Okay.
Back to the slides.
Yep.
Okay, so this was just a recap on what happens under the covers. So the mobile app starts and asks the ACS for a list of identity providers, and it'll return that in a JSON stream. After that, it'll do a request to the identity provider of choice, and the ACS will just give you a URL and say, here's where you need to go to log in, and on the URL is actually a redirect instruction that after the login, the identity provider will redirect you back to the ACS. So actually, it's the mobile app that does the whole login, but it doesn't really know where it's going. It just follows the instructions. So it goes to the login page, the user logs in and gets a token back. It is sent to the ACS. It's actually sent to the ACS by the application. The ACS will decrypt the token, translate it into its own. It does a claims mapping, so you can also do a translation of claims there, and it'll just send you to the application, the backend page, where it'll recognize the ACS token because it trusts the ACS, and then translate it to a cookie, which ultimately gets used on every subsequent service call. So the user is authenticated.
Yeah, question here.
How can we prevent session hijacking like this scenario?
Yeah, the question is how do you prevent session hijacking, just like I did in the in the demo. So the whole idea is that you do this over an HTTPS protocol. So the whole idea is that you have an end-to-end scenario where nobody can peek into your channel where you're communicating. And that all the redirects will be done in HTTPS. So if you looked at Fiddler, which I just showed, were all tunnels where we were over. And only the call that I did to my website was clear text, and I did that on purpose so I could hijack the cookie and use it in a different application. But normally there's no way to get to that cookie. And we could even make it a secure cookie by getting an extra signature on there that people cannot reuse the token other than in this HTTPS session. Okay, so that's the way you can secure that. Yeah, question over there. So can you repeat the question? I don't get it.
What advice do you have for providing your own IDP?
Oh, so the question is, what can we do to provide our own IDPs? Microsoft provides this platform, Windows Identity Federation, and with WIF you can build your own STS, which is a security token service. And this security token service normally can just plug into ACS. So we can just set up the trust there. Like I said, we can chain up different IDPs, and you can just plug in your own IDP and then have authentication being relayed to your front end there. And there you exchange the token back to ACS. And based on that, you can translate that back into a claim set that you know. Okay?
The basic advice is look at some standard protocols to use, such as WS Federation or SAML or something. That'll easily integrate into different types of infrastructure, such as WIF or other types of STSs. And you can, under the covers, implement your own data store where you store username, passwords, or some other identities.
Yeah. Question over there?
You mentioned the magic piece that goes with the front end of your server.
Yeah.
Can you talk about that? Is it an SDK?
Oh, yeah, so the question is, I was talking about a little bit of medging, which we had, the WIF block in front of our service. So what's going on there? So the only thing I've done here is, within Visual Studio, I've gone to Tools, and then to Extensions and Updates, and here you see Identity and Access Tool. So this is what I installed, and when you install this, you get the right click on your site, which I have over here, and then you can do the Identity and Access over here. And that will generate a little bit of changes in your web config. So in your web config file, what you will see is that they set up a whole bunch of stuff in terms of issuer registration, the thumbprint that's been exchanged, and all that stuff that you rather not worry about, but need to get to acquainted to when you do this integration. And it will be handled by the framework for you. So it's just a set of libraries, Microsoft.identity which are the references to the assemblies, and that will fix this all for you. And they will do the magic with the translation of the tokens and sending it back as a cookie, for example.
So WIF is Windows Identity Foundation. It's just a free add-on on the .NET framework. And actually parts of it are also now incorporated into .NET 4.5. So you can just use it and put it in front of a web app.
Is there any support for fingerprinting the machine?
So the question is there any support for fingerprinting the machine? So I think we should take that offline and have a chat about that. I'm not sure. So the whole idea is that you need to have an identity provider that does the integration with the fingerprint reader. Based on that, hand out an IDP token and then put it back to the ACS.
Sorry, I wasn't clear.
Okay.
I meant an IDing machine.
An IDing machine.
IDing the machine.
A unique identity on the machine, like a MAC address?
MAC address,
So I'm not quite sure what you're looking at. So
if I log into my bank right now
yeah.
on a machine that's in public
Right.
space here, they're going to say, I don't recognize the machine. Can you please provide me your secret questions?
Oh, okay, right.
So
Yeah.
some sort of a device token.
Yeah. So the thing is that if you take a look at devices in general, there's a set of APIs that you can call to get unique IDs out of devices. So for example, if you take a look at the Windows Phone platform, you just can very easily ask, give me the unique ID of this device. And based on that, you can send that along with your request and then do some stuff on that. I haven't looked at it, but I'm very sure that there are different APIs of getting that on the other platforms as well.
Desktops usually don't have it.
Oh, okay. Yeah.
No.
Okay. Yeah. So
Okay, moving on.
yeah. So yeah.
Just to illustrate what's going on under the covers in the app, and that's what we actually build a control for that we reuse over different apps. On Apple, what we do is when we fire up the app, we have a sign-in view control. It's just a subclass of UI view controller in which we have implemented the whole login stuff. So it actually contains a list view and a browser view that it alternates depending on its state where you're at in the login process. So what goes in there is actually the ACS namespace, because it needs to know where it needs to redirect and do the authentication. It puts in the realm. The realm is the address of your web backends. It's what actually identifies your app. And it's also necessary for ACS to know for what app you're trying to authenticate. And it puts in an HTTP cookie container because it needs something to store the cookies back in after the authentication is complete. So just illustrated by an empty platter here. What it does, it goes in the sign-in controller and it does its work. It shows a list, and the list is accessed via some classes, a JSON identity provider discovery client. It's just a simple REST client that we use to call the web service on ACS to get the identity provider list. It returns it, it shows it on the screen, and the user selects a identity provider. Then it'll show the web view on which we couple the web view delegate, and that handles actually the redirects and the different steps in the login process. Eventually, it'll just do the whole login and gets back the cookies and puts it in the HTTP cookie container. So you have your cookies ready, and you can put them on a service proxy that you can use on every service call. So to show how that looks, I'll just go over to my Mac. And I've fired up the app here in Xamarin Studio, and I've put in a couple of breakpoints just to show you the steps along the way. So I fire this up.
It's a recompile or?
Yeah.
Okay.
Obviously. So at first I've landed here in my app delegate, my startup, and it does a check if I'm signed in or not. So in this case, I should not be signed in. So what you'll see is it just uses a class to actually handle the login. So I'll just continue. And in this case, it has remembered my, my cookies from the last session. So I'll just restart the login. So I land here in my login class, and here you see that I fire up a new access control sign-in controller. So this is my controller, and I pass in all the parameters I mentioned here. So here's my cookie container, the namespace of my ACS, And there's also a reply address. And the reply address is where actually after all the login steps are complete, the browser view has to be redirected back. And this is actually our application to get the cookies. So it just passes that in, and this is all the information that our classes need to do the login. And then I'll just fire up the view controller here, and I've done a couple of customization steps here to put a background image on it. And it'll just fire up. And the first step you see here is that it loads up the identity providers. It'll use our discovery client and gets a list back from the ACS. So when it gets back, it's displayed in our view controller, and I'll choose Google in this case. And now we've landed in our web view delegate. It's the delegate that is linked to the web view that shows the login screen. Now at first, what you'll see is that it'll have me redirect, and I'm not sure if everyone can read it, but here's a URL to Google, to the Google sign-in provider with a whole bunch of tokens. And this URL is actually provided by the ACS. It knows how to tell the app, here's where you need to go to get your token. And the app just follows along. So it'll just navigate me to that. Now Google has already authenticated me, so eventually I get back from my app a set of cookies. And this is, in iOS, what we can do here is there is an NS HTTP cookie storage that a web view puts its cookies in along the way on a web browsing session. So I can read those cookies from here, convert them into just regular .NET cookies, and store them in the cookie collection. So when it's done, you'll see that this cookie collection contains, in this case, I think 2 cookies, 4 cookies in this case. And it depends on the token size how many cookies you get. And it'll just notify through an event the application that it has signed in and the cookies are ready to use. What we also do is when the whole login sequence is complete, we put that in a cookie container, so that's the empty platter you saw, and we also save the cookies on the device, so you can use them on subsequent application sessions. So it just gets persisted to local storage.
So one thing you need to note there, it's only 24 hours that you can do that, because otherwise ACS will just expire the token. So it's only trusted for 24 hours. If you want to keep it for longer than that, you need to roll your own identity provider to do that, or make an annotation to your server-side part to say, well, I hand out this additional cookie which can identify my client as well. Okay, so that's some tweaks you need to do to make that longer than 24 hours.
And it's a trade-off because expiration also helps session hijacking. When a cookie is expired, then it's not useful anymore. Yeah. Back to you, Marcel.
Yeah. So the thing is that we have the exact same thing going on the Windows platform and on the Android platform. So what we have here is what we created is a login view. Within that view, we configure the ACS namespace as well, the realm page, and the cookie container we would like to store the cookies in. The only thing we do next is we would push that into our login view. Then based on that say, well, we have an access control service signing control, and that's just a control that you can just drag and drop on your page, and then configure that to use those settings that I just mentioned. Based on that, it will go to the JSON provider and ask for the IDP list, and it will show that in a list. Based on that, activate a web view. And that web view will get the token that Roy just showed you. And it will start the navigation, and then the magic dance starts automatically. We don't do anything with that. We just navigate to the first one. And we respond to Navigator 2 events so that we can check where are we in the magic dance. So based on that, we can hide the control so you don't see the flickering going on for every page that you would be redirected to. Otherwise, it would be a very goofy look and feel on your device. Okay. Based on that, you get the cookie back, and from that, you can do additional calls. Same goes for Android. We don't go the animations here, but it's more or less the same principle that we use there. So what I would like to do is just take you through this as well for the Windows version of the app. So what you see is here that once I start the application, we get into what we call the login view. The login view next will be set to, well, what is the destination URL? This is the logon page, and I'm setting the cookie container. And based on that, it now knows where it can store the cookies when it's done. Okay, so this is the way I fix up the control. Next, what will happen is it will go and get the security tokens. It will ask for the security tokens on the sign-in control, and based on that, it will start doing its job. Now, its job is first to show me the list of identity providers that are available. So I will do a refresh on that, and when I have 11 in that, you see that I'm doing the JSON request, set up the event handler, and then call the async call to get the JSON list back. When I F5 that, you see now the list of items over here, and when I click an item, I'm going to select that particular identity provider, and over here you can see that this identity provider will go to this particular URL. Okay, so I will just copy this out and paste it, and what you will see is when I go to a web browser here, you will see that what my web browser will do when I do the authentication here. And you see that it now goes back to a page, and this page is especially made for mobile. Don't bother about the notification that we did, because what I'm using for Windows Phone is I'm using the script notify to notify back to the control so I can get the cookie there. So if you take a look at the source of this page, what you see is that I dumped out the cookie in plain text so that I can just push that on with the external notify here. You see that we also have a function called getCookie, which will get the cookie string as well. That's because we do multiple devices, and not each and every device supports a web view that has a notify option in it. So some we need to use the getCookie, and for others we need to use the notify function because we cannot call the JavaScript function. So there's some stuff that we needed to fix there. This is just a very simple part of an ASPX page, and we provide you with the code later on, which you can just put in your page and then get the results back and integrate with the controls over there.
So we see that the iOS has access to the cookie container that's connected to the web view, but it's restricted on Windows Phone, for example. You can't access that part of the stack. Yeah. So that's why we use this as a
it's more or less cookie hijacking what we're doing here, right? And on Windows platform, they try to avoid that, but of course you can find very creative ways of doing it in another way. Okay.
And this works.
It's just, well, when your app just wants to show its cookie, why not just put it in the page there and just grab it? I mean, we want to hand it out, and based on that, do a service authentication. So next, I'm navigating to the authentication provider. Well, you've seen the dance over there, and based on that, I do the login, and I get the cookie back in the script notify over there. Okay. So that's the way it works on Windows Phone. It's the exact same way as it works on the Android platform. Okay. So we have that running there as well. So with that, you might think, well, that's interesting stuff, and I don't want to fiddle around with that as you guys did for probably a few days. And you might want this stuff yourself. So what we thought is what might be a good idea to provide this to you all. Okay, so what we came up with is say, okay, we are going to push this on Codeplex. On Codeplex, we created a project. We're finishing up the code base, tidying it up a little bit, so it's for the public eyes to disclose. And then, depending on demand, we will create a NuGet package for it, and we also will create a Xamarin Store component for it, so that you can very easily integrate it in your environment. But we set here based on demand, because what we see here is that the room is not packed, and our days are packed if we take a look at what we need to do. So if there's demand, let us know, send a tweet out, catch us on Twitter, or email us if you really need this stuff. Then we will make the additional effort to make this available to you. So some of you might have already heard of something that's called the Windows Azure Toolkit. Who already knew that stuff? Windows Azure Toolkit? Well, the thing is that they built this Windows Azure Toolkit, put it on Codeplex as well, but now they deprecated it. Okay, and what we've done is we've taken more or less a fork of their code, annotated it, so it does not only work with simple web tokens, but also with the cookie containers. And we created it in such a way that it now works on all the platforms that are supported by the Xamarin toolset. Okay, and that's what we've done, and that's what we will provide to you if you, well, give us enough demand to make the effort. Okay, and with that, we will really thank you all for coming here, and we take questions afterwards because, well, time is up. Okay, thank you very much.
Thank you.
Any questions? Yeah.
So could you just use the native browser for the device instead of a web view and redirect it back to your application?
So the question is, can we just use the native browser and do the redirect? And the answer for that is no. And the reason is because your browser is completely separated from all the other apps. And there's no way to grab your cookie container in your browser view or in your browser app and just hijack that cookie or get the authentication information. So you really need to do it within your app. I'm not sure if that's the same for Android, because there you have the intents, and I'm not sure what you can ask from an intent. Okay, so I should have a look at that again. But the programmer working on the Android stuff showed us that they could not reach out to the cookie container as well, and we needed to use the web view instead of that. But yeah, that was the reason that we used a different approach there.
Plus, we also did it for the user experience, that you stay inside the app and not have it switch around. But it depends on the platform what types of inter-process communication you can do and pass out the tokens.
So that's a no on Windows Phone.
It's a no on Windows Phone. It's a no on Windows 8 for sure. It's a no on iOS.
And like if you sign in to Twitter, for example,
right.
You can use that as a sign-in for in your app, and it'll just
yeah, but that has to do with
Facebook
something. So that's more the native integration of your phone device with Twitter and Facebook, for example. So Windows Phone, Facebook is also very integrated, right? But I'm not sure how open the APIs are currently. I know that when they started, it was all closed, and they're trying to open up more stuff each and every time. I'm not sure how it is with the iOS APIs on that part, if we could just use their tokens or use their authentication mechanism.
iOS does. Some iOS apps do that, yeah.
Yeah.
They just swap the browser,
yeah.
So what guarantee does the user have when it's in-app like that they're actually entering their password into a URL of Facebook as opposed to providing their credentials to the app?
Yeah, so the question is, what guarantee do we give the user that they are not punching into any mock-up that we just created and punch their username and password and we hijack their stuff? And the answer to that is, yeah, it's your trust. Are you trustworthy as an app provider, I think. That's the big question there. We cannot interfere now with entering the password because, there would be another way of doing that, I think, but there's not a real guarantee that I would give you or could give you in that respect. No. Other questions? Yeah, question over there.
What do you have to do on the enterprise Active Directory side to add it to Azure Active Directory?
Okay. So the question is, how could I integrate an ADFS Active Directory into the Windows Azure Active Directory? And the answer to that is that you need to have ADFS in your enterprise, and you need to exchange the WS Federation information with Windows Azure. So you can get that from your ADFS service. And then the only thing I need to do is when I go back to the ACS portal over here, now what I could do is identity providers over here. And when I click that and sign in again, then I could say I would like to add another identity provider, and I can say just use a WS Federation provider here. And here you provide all the information that is required and given by ADFS to do the integration. And based on that, it will just redirect you to ADFS to do the authentication.
But you need to install ADFS version 2 on top of your AD for that.
Yeah.
What's the comfortability factor right now in the industry with companies allowing Azure to see Active Directory information? You know what I mean? Is there still some uncertainty there? You know, are people scared of doing that?
So in general, I would say that people are scared of anything that has to do with Active Directory in the cloud. So what I see is that, but for one of our clients, we did this. We have the ADFS running and using ACS for authentication.
Yeah, actually with a Google, with an Oracle backend Active Directory. Yeah.
So some customers are, some aren't. One of the things we've also done is integrate Windows Azure and domain join, for example, machines in your own Active Directory. And for that, you need to install stuff on your AD server. And some customers say, no way, you're getting near to my AD server. And others say, oh, well, come along and just let have a party there. So it really depends, yeah. There's no general answer to that question, sorry. Okay, with that, thank you very much and enjoy the conference.
Enjoy.